Students, I am discussing about location and location principles. In this session, the reference book for this lecture is An Introduction to Jig and Tool Design by MHA Kempster, published by Viva Books Private Limited, Chennai. As you can see in this figure, a component in space can be free to enjoy 6 degrees of freedom. It can be moved along the xx, yy, zz direction. It can be rotated about xx, yy, zz directions. So these are the 6 degrees of freedom that a component can enjoy. You have to arrest all the 6 degrees of freedom when you want to locate it on a jig or fixture, or you can arrest the required number of degrees of freedom. Let us say the component to be located on a jig or fixture is of a prismatic shape like this. How can you locate it? That we are going to discuss now. You can simply use 3 number of locating pin. So these 3 locating pins are fitted to the base of the jig or fixture. So these 2 pins are fitted along a line, and this pin is fitted along a line which is perpendicular to the already fitted pins. So this is the component to be located. This is the top view of the arrangement. This is the isometric view of the arrangement. So these are the 3 locating pin we are using for locating the component onto a jig or fixture. So when you push the component, the side surface is touching on the cylindrical surface of these 2 locating pin, and this surface, vertical surface of the component is touching on the cylindrical surface of this locating pin. So in this way, we are able to constrain all the 6 degrees of freedom of the component. So if the component to be located is of a prismatic shape, we can make use of this kind of locating principles. If the component is of cylindrical shape, then how can you locate it on a jig or fixture? We can use 2 locating pin fitted on the base of the jig or fixture. So when you push the component against these 2 locating pin, it is moved until it is hitting on the side surface of the 2 locating pin. So this is how we can able to locate a cylindrical shaped component on a jig or fixture. If a component is having a hole already available, then you can make use of the hole for locating the component. So you can make use of a location post which is engaging with the hole available on the component. So this is the location post which is fitted to the base of the jig or fixture, and this is the workpiece or component. Component is having a hole. This hole is used for locating the component. So alternatively, we can make use of a conical locator also if the component is having a hole. So the component is placed over the conical locator, and the conical surface of the locator is engaging with the hole on the component. So this way you are able to constrain only 5 degrees of freedom. The component is still free to rotate about its vertical axis. We have to make use of additional locating element if you want to constrain all the 6 degrees of freedom. If the component is having a shape of a cylinder, this is one way of locating it. The other way is you can able to place the component over a conical locator which is having a cavity in the form of a cone. So the component is placed over this cavity, and we are making use of the bottom circular edge, so which is going to be engaging with the conical surface, and this is how you can able to locate the component. So this is one way, and this is another way. already we have discussed. So what is V location? So this plate is having a V groove for locating the workpiece. So this is the isometric view of the V locator. So we can fix this on the base of a jig or fixture, and if this is the component is pushed until the cylindrical surface of the component is touching on the V surface of the fixed V locator. We can able to constrain the 5 degrees of freedom of this component using this fixed V locator. This figure shows a sliding V locator. So here this plate is made to be moving this way. So for the purpose of loading and unloading, we can make use of one fixed locator and one sliding V locator. Suppose that the component is having a shape as shown in this figure, then using one fixed V locator will not be helpful in constraining all the 6 degrees of freedom. So we have to make use of one fixed V locator and other sliding V locator. So only then you can able to load the component and unload the component onto a jig or fixture. So if you are making use of both of fixed type, then loading and unloading the component is a problem. So the sliding V locator is shown in this figure. Now this is sliding V locator. We have to add other elements in the design so that the sliding V locator is properly getting guided using the guide plate. So this guide plate is shown here. The exploded view of the sliding V location system. This is the sliding V locator. In order to properly guide it while it is moving, we are using a guide plate. The width of the slot on the guide plate correspond to the width of the sliding V locator. If the width is 30 mm, this should be 30 plus a small clearance. So when you fix it over the base of the fixture, the V locator can be guided while it's moving in and out. In order to make it move in and out, we are using a threaded hole on the side surface of the base of the fixture, and this element is engaging with the threaded hole. When you rotate the knob, it is moving inside the threaded hole, and as a result this flange, which is part of this element, is engaging with the slot on the base of the V locator, and in this case the V locator is moved towards left side. You can clearly see in this figure. So when you rotate this knob, this is moving inside. As a result, this flange is moving towards left side, and since it is engaging with the slot on the bottom of the sliding V locator, the sliding V locator also move towards left side. So the component is held between a fixed V locator and sliding V locator. So by rotating the knob in the clockwise direction, this V locator is made to move towards the component, and the component is properly located with respect to, it is constrained with respect to all 6 degrees of freedom.